And your camera is that one. That one is yours. Hi everyone, this is Lorenzo Franceschi Bicchirai. I'm a reporter at Motherboard where I write about cybersecurity and hacking. I know we said we will be back tomorrow with more stuff, but actually we're back today, because why not? We're here with Omer Farouk, security analyst at ISC. We're still in Baltimore. And what we're going to do today is a quick demo of basically how to hack a router with a simple tool called BURP Suite. And yeah, this is Omer Farouk. And before we start, why don't you tell us a little bit about yourself and how you got into security?
Yeah, so from an academic training point, I'm an engineer, and tracing backwards, I've always been a curious kid, thinking about building and more like breaking things, and then somehow that led me to go to engineering school. And then after a while, when I was for building stuff, I started got involved in hacking and ethical hacking, and then reverse engineering. So, and that's where I spend most of my time now. And with a good engineering background and understanding of how things work, you know, it's always a very fun experience to look at new things and how you can break them.
Mm-hmm. Yeah, so can you tell us, give us a quick intro what you're going to do, and then let's get into it.
Sure. So today we will focus on how to hack a router, and specifically we will talk about how to use simple basic tools for HTTP traffic monitoring, and we'll look at how to inspect traffic, how to edit it on the fly. And one good use case to show all that is to exploit something called client-side authentication model. Client-side authentication model is has been prevalent on a lot of routers and networking devices. And we have a device here today that we will try to hack it and see how it goes.
Awesome. And just to clarify, like, you don't know if this device is vulnerable or anything, or?
This particular device at this point is known to be vulnerable, but yeah, we will attack it from a point of view of not knowing if it's vulnerable. We will go look through the code. We'll look through the client-side authentication code in the JavaScript to see if we can find any clues. Take those clues and bring it back to the inspector and try to see if we can get access to the client to the device itself.
All right, let's do it.
Sure. So, but before we get into, so one of the things why we want to make sure we answer the question of why this is important, and specifically for a router, what impact does it have? If an adversary is able to get into a router, if they can get into the administration of the router, they can actually open up configuration ports. They can traverse traffic. They can reroute traffic, and most importantly, they can traverse the network. And once you're on the network, you can go ahead and look around and poke around and see what other assets are unprotected. Take advantage of other weak devices and try to see how you can get to that. So once you have access to a router and you can play around with it and do what you want, you have ultimately taken over the network, and you can do a lot of other things to get to the data or to the assets that are on the network. So in today what we will do is we will walk you through how to bypass the authentication model on this particular router. This is a Belkin router that is built for small offices and homes. It is very prevalent in a lot of people have that. It's commercially available. It's available for sale, and it uses very well known. It uses client-side authentication. So we're going to go ahead and show you how it works and how we can look through code and figure it out. So let's get started. So first thing, let's talk about our setup. We have our router, and in this case, we have the router connected directly to my computer here through hardwire. It could be if you are on a network, you can do the same thing through a wireless network, and you need to know the IP admin or IP administration, IP address of the administration page on the router. Usually that is printed on the back of the router, or most router companies have all that information on the internet. So once you have figured that out, you want to make sure you can get to it, and you can do an easy way. One of the easy ways to make sure you can get to it, you can just ping the IP address of and you have access. In this case, we do have the router connected directly to the switch here, and then we will try to get to it. Okay.
And just for the beginners, like why is that IP address the router?
So
Or how do you know?
in our particular application, we have set up the router on a specific address, but like I said before, the IP address of the administration of the router itself is either printed or on the back of the router, or it's easily can be it's in the manuals, which are all online. So whatever the router you're trying to get to, you can just figure that out by looking up the documentation and get to it. Okay. So in our case, the router is we can ping it, we can get to it, so we know we have access to it. So the next thing we do is we go ahead and get to the router's main page. The way you would do that is you would go ahead and type in the IP address and then just go to it on any web browser. In our case, we're using Microsoft Edge. When we get to it, on this particular router, it shows you all kinds of firmware options and different addresses and of the WAN type and the LAN and also the firewall in the settings. In this particular feature, what we want to do, for example, we might want to disable the firewall. To disable the firewall settings, you can't just do that without logging in. You have to go in and log in. Now, an adversary generally would not know the password, and most will not know the password. Sometimes some users do not change the password and keep the password default, but you should change the password and make it something that's more harder to break and follow some level of has more characters, more than 8, or follows some kind of pattern that is hard to break, not simple default passwords. So our goal would be as an adversary to, for example, to go ahead and disable the firewall. To do that, we would have to enable it. We would have to log in. To log in, you would try a password, and if in our case, let's try 1, 2, 3, 4, 5, 6. Let's assume in this case, the user has a very simple password. And what you would get is an incorrect password. Okay, so now we know that. Now let's look back. So now we do know that this particular router does use client-side authentication model. So what does that mean? Well, that means that the actual authentication of the credential happens in your browser rather than happens on the device. So when you do click on the submit button on this web page, the traffic is routed back to your application running on your browser, and a JavaScript goes ahead and checks the credentials and see if they match what they should and allows or disallows access. So so how do you go ahead and look at the code? You look at the JavaScript code, or you start poking around. The first thing you can do is you can go ahead and open up your web browser debugger or a console. Most of them can be activated by pressing F12 key on the browser. So once we do that, we have a debugger, we have console, we have other handy tools here. What we will do is we can go ahead and look at the files, and it brings us to a file that right here is called login.perm.prst/stm, which has all kind of Java code, which all has all kinds of HTML code follow along with the bottom with the script. So if you look through the script and look carefully, you see a lot of hard-coded values. You would see a lot of different numbers here. What does that mean? Well, that means that the router has a lot of values that it has stored as defaults, and goes and tries to match them or tries to set them as you go along.
And that's always a bad thing, right? Or a good thing for an attacker.
Well, it gives you a lot of places to poke around, and you can take a look and read through the code and try to figure out what they're trying to do. So a lot of times they might have a lot of hints there that you can start and poking around from. So it gives you a very good starting point from. So once you're in here, you'll see that obviously the router supports, for example, DHCP. So there is a setting for starting IP addresses for the start IP addresses and the end range for the DHCP. Now, if you keep scrolling down, there is a variable called password. Well, that looks interesting, right? But what is that password? What does that mean? Well, if you look closely, you would see that it's a long string of random numbers and characters. well, okay, well, see, we have some kind of knowledge about some kind of password is being checked. Now, if you look below, there's a line of code that says if auto check password hex equal MD5 document TF PWS value. Okay, so it seems like it's checking this password value against some kind of MD5 sum of something called PWS value, and looks at that. Okay, well, but we want to go ahead at this point and see what happens when we go ahead and submit button and we want to trace the traffic. So one of the other tools that we're going to use today, and it's a very handy tool that I think that that is very useful, is called BURP Suite. This particular suite, tool allows you to, one feature of this tool allows you to proxy all the browser traffic from your browser to the tool before it gets to the end web service. What that means is before the traffic hits the web service, you can inspect, edit, and drop the data before the traffic that's being generated from your browser. So in this particular case, what we would like to do is we would like to say, so since we know that this particular router has client-side authentication, we want to make sure, like to see what a request looks like. In HTTP world, or what that means is that when you press that submit button, we should see a post on the web service. And then the post will have some kind of data or parameters. So we would like to see how this particular logic set on this page creates that post message, and how that gets created, what that looks like before it gets to the web service. So let's go ahead and try that basic password again and try to intercept our traffic and see what that looks like. So I would type in 1, 2, 3, 4, 5, 6 here. And before I click on submit, I would like to enable my interception of the traffic. Now, keep in mind, there might be a lot of you might have other tabs or might have other traffic going on in the background that might be active at the same time. So this will start intercepting those traffic. Another thing to note at this point, to enable this kind of tool, to intercept and proxy your traffic, you have to go and configure your web browser, and you have to enable proxy through a local loopback. In this particular scenario, you have already done that, but to do that, you usually just would go into the settings, and underneath the settings is usually a proxy setting for most web browsers, and you would go in there, and then you would enable the manual proxy setup, and it would populate the address to your loopback address, and with port on 8080, which is all the HTML traffic, and then you click on save. Like I said, we have done that already in this step, so we'll just keep going. Now, we go back to the BURP Suite, intercept is on, we can put in the password, and we're going to click on submit and see what happens. We click on submit, and we have intercept. So now this particular packet that we have been looking at for a while is not something that's related to what we are doing, so we can just forward or drop it. In this particular scenario, we will forward all packets that are not related to what we are doing today. We forward that, there's some other traffic, we forward that, and we forward that packet, all these packets that are here. Okay, we must have missed it, so let's try it again. There we go. So we have more packets to look through, and there you go. So we have a packet, and it's no, not a packet, I'm sorry, we have an HTML message, and then we will go ahead and look at the parameters. This is a post, and we can go ahead and see all the parameters. So there's two parameters in this. One is called total M seconds, which has a big number into it, okay. And the other one is something called PWS. And the PWS has a long string. This string has a bunch of different characters and seems like random data, or seems like something we don't look like a password. But if you go back to the logic that we looked at before, and remember, and we notated that there was something called PWS value being set, and that's where we were generating MD5 sum. Maybe. And we also know the fact that this is client-side authentication model. Maybe what's going on is that this is a hash, because MD5 is a hashing algorithm. So what maybe is going on is that once we put in the password here, this password gets hashed and gets sent back to the authentication service, which is running back on your client browser. And what is happening is that it's probably checking to see if the hash of the password that you entered equals the password that's already been hard-coded here. Okay, so that's a theory. We can go ahead and try that. So in this particular scenario, what would we do is we would take the hash that the password is set to, we would copy it, go back to the editor, and before it gets sent out, because remember, the BURP has not sent this traffic out. It has held it for us for inspection. So we haven't actually forwarded this or sent this data out. We would go back and edit this field and go ahead and type in the password or the hash of the password that was in the client-side authentication code in the JavaScript. Press enter, and then forward this, which means we are sending it back to our client browser to go parse through this code. We forward it and turn the intercept off, which automatically sends all the traffic. Okay, interesting. We are back to the firewall screen. So this screen was not, or this configuration was not available to us without having the password. So what we are seeing now is that we have access to the router. We are logged in, and we can change any kind of configuration we like. We could actually, in fact, go ahead and disable we can disable firewall, which will disable all ports on your router and allow all a different set of type of traffic to enter the network, which you can enable to use as a pivot point to traverse the network. So we are at this point, we can see we are in the router, and we basically can go ahead and make any kind of change we like. Okay. And we are logged in, and we can change the WAN settings, we can change the wireless settings, we can go ahead and change it. We can go look at the SSIDs, we can go look at we can go change the wireless password, lock people out, cause all kinds of situations where people would not be productive and kick them off the network or take the data that was on the network. So this was a quick test or a quick overview of how client-side authentication model can be exploited using simple tools like a browser and BURP tool suite. And as you can see, this is a very it was a very commonly method of doing authentication, and it's very weak, and it can be breached with very little tools and very little knowledge, and from a read up using internet sources, and with reading of the manual of the routers and understanding of how the authentication in the browser works, a person who with a little technical knowledge can go ahead and exploit this. And the workaround from a vendor point of view is for one, do not do authentication on the client browser. Go ahead and move that into the router or the device itself. And the reason why that will work better is because now not only the adversary has to first get into the router and then go figure out how you do authentication. It's not actually executing on the client browser, which is out of the control of the device itself.
So why would vendors set up client-side authentication, given that it's, as you've demonstrated, it's inherently flawed?
I think it was done because one, the idea of security by obscurity. Initially, people thought that basically this router is a few years old, and at that, vendors weren't really thinking that people would go ahead and look in how the authentication model would work. They thought this is complicated enough for normal users to exploit. But as we've shown, any user watching this video can go and figure this out if their own router does this and exploit this. But it's a weak model of it basically shows that security by obscurity doesn't work, and they weren't really designing for the highest level of security in the first place, but more for function.
We mentioned this before, but if I'm a user or if someone here on the live stream has one of these routers or something similar, how can they make sure that this is not possible, and how can they make sure that they change their default password?
So, like I said, they should definitely change the default password, but for this particular case, for a client-side authentication model, default password or not default password will not really help because you can go to it. But I think what people should do is, one, upgrade the devices and patch them. Most vendors will patch the devices and change authentication models, and so that would work. So keeping the device patched up or keeping the device updated helps. If you have a device that still uses client-side authentication model, you could go ahead and replace it, or you could go ahead and make sure that the administration portal is only available locally on the network. So you can turn it off and then make sure that the access is limited.
Mm-hmm. And I don't know, I guess this is probably a tough question, but like, is it usually better to go with whatever your ISP provides in terms of router? Because that's maybe something that the ISP takes care of, or should user go with their own routers? Do you have any advice, or when some of your friends that are not technical ask you
Right.
stuff?
Well, I think that so most people, so security, from a security standpoint, which router you go with, it depends. It's not a simple question. It's not a binary question of saying yes, go with your router that's provided by your ISP, or go with X router on the internet. I think what people who are about to are going to be using routers, or going to be updating or upgrading routers, they should read about it. Think about what kind of security is built in. As security is becoming more of a focus throughout the industry, a lot more vendors are spending a lot more of their energy making sure the devices are hardened. So I think what the right answer would be, or the correct approach would be, to go ahead and get a little more familiar with what basic security looks like, what are the things that are built into the router that you're about to procure, or about to buy, or about to take from your vendor, and read about it a little bit. I think the internet, the stuff on the internet is quite simple and quite easy to understand, and you can make a really good decision based on that. I think some of the routers provided by the ISPs are in a good state, but a lot of times their route is always better that you can purchase on your own. So it also depends on budget and time and what the asset on the network is. So there's no one answer.
Yeah, there's no perfect answer, and I guess that's always a good advice. Do a little research on your own before buying a router, or before signing up for your ISP. Look around for forums. I'm sure people have, a lot of people have gone through the same process you're going through. And that's also true for Internet of Things devices, which are, I guess they are at the state in terms of security where routers were maybe 10 or 15 years ago, right? With very low security. So do some homework, and remember that this stuff is this stuff is not trivial. This stuff is like sitting literally between you and the internet at all times, and if it's not safe, it could be dangerous. And same thing with Internet of Things devices. Some of them are toys, but baby monitors, you don't want a hacker to get into your baby monitor and start messing with it.
So a lot of times you're exactly, you're right. So a lot of times a router is the gateway to your devices, and which might be a lot less hard and a lot less security conscious than your router. So you definitely want to make sure you spend some time and do your homework to find the right router.
Yeah, I think that's kind of it. Is there anything else they wanted to add, or one more lesson for people?
Just go ahead and look at your router and maybe upgrade it, and take a look at what kind of open vulnerabilities are out there. I think anybody can just write down their router number and just do a simple Google search and find out what open vulnerabilities are against it. I think that always helps. And the routers are pretty, are becoming a very important part of your home network. So I think as a user, and even as people who are building as vendors, are definitely taking notice of security. But as even users, we need to be more conscious of what level of gateway to our networks we have in our houses as we go along, and as everything becomes more digital.
Mm-hmm. Yeah, and if you want to play around with the same tool that Omar was using, it's called BURP Suite. You can just Google BURP Suite. There's a free version. There's also a professional one, but you can just use the free version to do what you just did. Right.
And today we use the free version to show this. Yeah,
so play around with it, get to know your router, and get to know what happens in the background. Thanks again for watching, and we'll be back tomorrow. And last thing before we log off is I forgot to mention it before, but we published a guide called The Motherboard Guide to Not Getting Hacked. There's some basic advice that anyone can use to be a little bit more safer online. Just go to motherboard.vice.com/security-guide. And yeah, thanks again, and see you guys tomorrow.
Thank you.